Hello, welcome to this module. And in the last module, I think we looked at the JDBC part. And that was the first part where we have seen how to obtain a connection with a database from a Java application, and the three basic components, the three basic things which are required for interaction with the database, how to get a statement, a prepared statement or a callable statement from a connection, fine, and the methods in those, the methods from the statement called execute, execute query and execute update. Fine. One thing to remember here, these three interfaces, statement, prepared statement and callable statement, are actually a hierarchy. Statement, the prepared statement extends from the statement. So all the methods from statement are inherited by prepared statement, and callable statement extends from the prepared statement. That is, it is inheriting methods, all the methods from prepared statement. So callable inherits from prepared statement, prepared statement inherits from statement. Fine. So methods point of view, yes, we'll have that kind of a hierarchy, that's fine. Now continuing with the method, we have seen those methods called execute, good for DDL, that's fine. We have the method execute update for DML, and that could be very easily be done. Those two are fine. But the third method, the execute query, it returns an object of result set. Result set is nothing but the content of from a data, the content as obtained from a select query, various columns, fine, from various columns of a particular table, or maybe there's a join or whatever, fine. So the result of a select, that's fine. So we're interested in actually having the a Java application may be interested in looking into those data values. So how do we use that? How do we use that result set? And so fine, this module is more about using result set and using those other two things, the prepared statement and the callable statement. Fine. So first thing is, how do we fetch the values which we have got through a select query in a result set object. Okay. So a result set is nothing but it is having the data from a table related to rows and rows and columns for a table, or maybe a join. Fine. So there are a number of columns which are selected. Now one thing here, in the result set, one part is the data, one part is, if we ignore the data part, it is nothing but the columns. What are all the columns we have in the result set? Information related to the columns of a result set are available through another interface called result set metadata. In the result set, once you got a result set object, in the result set, we have this method called get metadata giving us an object of result set metadata. The result set metadata is containing information only about the columns of the result set. Fine. It has no data part, it has only the information, it's a metadata which is information about the columns of the result set. Okay, so for let's see what we can. So once as far as result set is concerned, once you have obtained a result set object, from that you can use the method called get metadata, get an instance of result set metadata, and then let's see how do we obtain information about all the columns in this result set. So result set metadata, let's now switch to the methods of the result set metadata. In the result set metadata, you will find method, you would like be interested, first thing you will have is, you'll be interested in knowing how many columns do we have. So for that, yes, we got a method called get column count, it returns an integer value. Fine. So that's fine. Now all other methods in the result set metadata have one parameter only, and that parameter is a column number. Remember one thing, in java.sql package, wherever we talk of number, yes, for example, when I'm talking of a row number or a column number or a parameter number, it doesn't start from 0, it starts from 1. Fine. For example, in collection framework and all those things, we normally talk about index values, they start from 0. But in java.sql package, wherever yes, everywhere we start numbers from 1. So yes, if I say column numbers, yes, it starts from 1 and not from 0. So we have our get column count as the first method in the result set metadata. The other methods, what is our other interest? Our interest is to know about some information about each of the columns. So some or the other kind of information about any column could be obtained by using the method and passing the column number as a parameter. These column numbers, remember, start from column number 1. Okay, so let's start with looking at the various methods here. Fine, our interest could be, oh, what's the name of the column? So we have a method called get column name. Takes parameter always. Fine, all methods here except for that get column count, all methods are taking only one parameter, which is the column number. Fine, so get column name gives us a string. Fine, so name of the column. What's the other thing? Oh, you are interested in the type. For type, you have a method called get column type. Fine, parameter, column number. What does it return? Oh, you're expecting a string here? No, it's not a string, it's returning an integer value. Okay, fine. Oh, what is this integer? Column type? Yes, column type here is the SQL type. It's not the Java type. It's here, it is a SQL data type. SQL data type like the varchar, the numeric. Fine. The various SQL types are there: byte, fine, char, binary. Oh, fine. So the various SQL type, date, time, there are so many different data types. But here it's an integer value and not something which we expected to be like a string. So yes, what do we have? What is this integer value? For this integer value, we have a class called types. In the java.sql package, there is a class called types, which is only full of public static final int declarations. So there are integer constants. This java.sql.types is only full of integer constants for the various SQL data types. So there is some public static final int varchar equal to some value, public static final int numeric equal to some value, the various constants which are available for all the SQL types. So every SQL type, here we consider the ANSI types. Fine. So you may not find something like varchar 2, which is specific to Oracle, or number, which is again specific to Oracle. Fine. This is JDBC. It is following the ANSI standard and not any proprietary thing. Okay. So yes, you'll find integer constants for each of the ANSI SQL data types, and they are available in the types class. Fine. So this is what fine. So integer constants being defined here, and then the next step will be, yes, so this is one thing. So get type returns int, get column type returns int. Next method, oh, get column type name. Yes, this is where we get the string. So get column type name returns a string for us. Okay, so fine, as a string, whatever is the column type, again the type is about SQL type and not about the Java type. But one thing, corresponding to every SQL type, there is some Java type which is more appropriate. For example, if it is a varchar, what's the appropriate type for Java? Oh, if it's a varchar data type in my database, I would like to keep it, get the value in the form of a string in Java. Fine. So string matches the varchar of database. Fine. SQL. Same way, if we have a date type, oh, for date type, oh, we do have java.util.date, but instead of using a java.util.date, what has been done for us is we have been provided with more specific types which are very appropriate for handling SQL to match the SQL types. We have this, so we have the time, date, time, and the timestamp, which are the data types in SQL. Corresponding to these, we have the classes called java.sql.date, java.sql.time, and the java.sql.timestamp. And one point here, all these three classes, date, time, and timestamp, they are extending from the date class. Fine. The date class, which is the java.util.date. Fine. Okay, so keep that in mind. They all three are actually dates only, which manages our time in millisecond values internally. Fine. So the date, time and timestamp. Fine. So we got data types for this also. We got other kind of data types. So for every data type, for every SQL type, there has to be some or the other Java data type which is appropriate. If there is something numeric, maybe here you might like to take it as a, in Java you might use a double or a float or a int or a long. Fine. If it's a date, you should be using java.sql.date. If it is time, you should be using java.sql.date. Or we got some types like blob type, the glob type, or even for those, we got our interfaces called java.sql.blob, we got the java.sql.glob. Okay, we have more complex structures in SQL, like we have got arrays in SQL, or if you got arrays in SQL, or we got java.sql.array class here. Fine. So for every type in SQL, we have some or the other appropriate type available in Java. There would be a class or interface. If it's not there in the proper Java API, it has been added into the java.sql package. So you will always find some appropriate type for every SQL type. Now what we have is, yes, many times you might like to see the mapping here. So for any particular column, whatever I have, maybe I'm interested in knowing what is the most appropriate Java type here. So for that, yes, we have a method called getColumnClassName. We have a method getColumnClassName, column number returns a string. So name of the class, name of the Java class which is most appropriate for this particular columns SQL type. Fine. So we got these kind of methods. We got lot of other methods in the java.sql package. For example, you even have method like get column display size. What is the appropriate size for this particular column, which I might use in my application if I'm allocating some space for it. Fine. Or we might have something like we might be interested in some other metadata related to the SQL, so get catalog, or okay, or you might be interested in knowing, oh, this column comes from which table, or this column belongs to which schema. So we even got methods like get table, get schema to give us the table name, the schema name for a particular column. So given a column, lot of information is available through the API, which is through this class interface called result set metadata. So result set metadata is all about information about the column, any column informations. Okay, fine. So fine, that was result set metadata. Fine. Let's continue further with the other methods in the result set. Fine. Our interest mainly is to get the data out from the result set. Fine. This was the column information. Fine. We are interested in getting data from the result set. Now this data is managed in the form of rows. There are various rows in our result set. Fine. So how many rows are there? Oh, no, we don't have a method to get straight away the count of the rows. Okay, but yes, we will. What we have here is we got methods for navigation within the rows of the result set. So row wise navigation is possible within the result set. So if you want to obtain any information, any particular cell, let's say, you should first be locating on the appropriate row, and then for your current row, so it is managing something like a current row information. So for the current row, you can then ask for the value from any particular column. Fine. So let's see, we got one part is methods for navigation within the row wise navigation within the result set. So how do we navigate row wise within the result set? So various methods for that. First thing, yes, initially as soon as you get the result set by using the execute query method, the result set which you have obtained, we got a special row position called the before first. So when you just got the result set from, you just got a fresh result set, your initial current row position is before first. It is before the first row. Similarly, there's also another special position which is after the last row. So we have got before first and after last also as some special row positions. Fine. And then yes, we got methods like, okay, if I want to start to look at the first row, I have to use a method, or you want to go to the first row from the beginning, or rather moving to the next row, you have a method called next. So if you are on before first and you say next, you should be moving to the first row. So from so here, like you are saying, okay, you want to do a row wise navigation. So one navigation is use the next method to go to the next row. The next method would return a Boolean value here. Fine. So the Boolean value returned is whether the next row is it isn't the after last. When you say next, and if you reach the after last position, it would then return a false value. Fine. So next. So if I want to navigate over all the rows in a particular result set, I would rather use the simplest way should be just opt in the result set. Fine. While whatever that result set, let's say result set is rs, so I'll say while rs dot next, and the whole loop is there. Fine. What you want to do for that whole row, fine, that would be within the while loop. Fine. So applying something on the whole row. So while rs dot next, that return value Boolean. So it goes from beginning up to the till it has reached the after last position. Fine. So we got position like before first and after last. Navigation wise, next method goes to the next row. Same way, we also have a method called previous to move in the opposite direction, going backwards. Fine. So we got a next method returning Boolean. We also have a method called previous that also returns a Boolean. Fine. We can go to a specific row by row number also. Fine. So we have a method called absolute, where you can pass a row number as a parameter and move to a specific row. You can move to a row relative to the current row. We have got a method called relative, takes a row number and moves so many rows backward or forward. Okay, so two methods. Absolute takes you to a specific row. So you can say, absolute 5, it will take you to the 5th row. What happens if I give a negative value to the absolute method? You can also give negative value. If I say absolute -3, it takes me to the last third row from the last. So negative values take you to the from the bottom, fine, row number from the bottom, fine, in the opposite direction. So that way you can use absolute method to move to any specific row by the row number. You can move from the beginning or from the end by giving a negative value. The relative method, whatever is your current position, from that moving forward or backward by giving a positive or a negative value. Fine. And then, so we got this absolute relative that can take you to any row. Again, special rows. We have rows, I want to have we have even a method called first. So anytime you want to go back to the first row, first method takes you to the first row. This would also return Boolean because it's not necessary that you got a first row. There might be 0 rows. So if you say first and there are no rows at all, that should return a false value. And same way we have the method also called last to go to the last row. Fine. And then we also have method called before first and after last to move to those special row positions. Before first is one special position, after last is also another special position. Fine. So all these are methods for doing some navigation, row-wise navigation within the result set. We also have another method called to know what is your current position. Fine. What is the current row number? So see, we don't have a method like getting the total count of how many rows I have. But what you could always do in that case is, I want to know the row count. Okay. Use the method last to go to the last row and use the method called get current row. So fine, we have the method called get row. I think the method is get row. And when you say get row, it gives us the row number. Fine, whatever is the current row number. Fine, so it returns integer value, what is the current row number, and that way you can find the, so move to the last and get the row number, that's it. So you can find the total count of how many rows are there. Fine. And okay, so navigation, row wise, getting to know the current row number. Fine. So that's navigation part, but fetching the data part. Okay, how do I fetch the data? To fetch data, yes, we don't have a single method here. Okay, depending on what type of data it is, from which column you are trying to fetch the data. For each type of data, there would be a different method. Fine. We got the get methods. We can say, oh, there's a whole series of get methods. We call it as get xxx methods. Get something, get xxx, the type. Get string, for example, would require us, would give us a string, because I would use a get string in case I find a varchar. But if I find this column is actually a date column, I'll use the get date method and get it as an object of java.sql.date. So yes, for each data type we have to use a different method. Fine. So we got the get xxx methods. Xxx represents a type, the type of data you would like to have it as. So fine. So we have get xxx methods. It's being overloaded. Each of those xxx is overloaded. So if I say get string, it's overloaded. You can, in get string, you could pass the column number as parameter, or even you could use the column name also as a parameter. So you could get it by number or by name, either of them. Fine. Getting the information by number or by name. And most of the time you would prefer using a name, because numbers may be here and there. When I say star, I don't know which one will be first and which will be second. Fine, it's not determined, but yes, if you are going by name, yeah, you get the exact value. You've got the exact column there. Fine. So get xxx methods returns xxx. That is, get string returns string. Get date would return date. Fine. Get time would return time. Fine. So that way, get block returns block. Okay. So fine. Get xxx methods to extract the values from the table, from the result set. Fine. And then once the result set, fine, once we have obtained the result set, fine. So this is how we get the values from the result set. Now other things which can be done on a result set. Okay, another point. A few properties about result set. A result set has a type. What is the type of the result set? Well, this is a result set. This type of result set is a forward only result set, in which case methods like previous, methods like first, methods like before first, no, those won't work, because you can't move in the negative direction. So we have a forward only kind of result set. But how do we determine whether a particular result set, or how do I decide I want to have a result set which is not forward only? Okay, when is it going to be decided? Okay, oh, we want to have result set which is, we want to, when I say execute query, no, we don't have any option to say whether, whether I would like to have what kind of result set. I want a forward only result set, or I want a, navigable. Fine. So you have forward only result set, or you might have a, what we say, navigation. One second. Scrollable. Yeah. Fine. So fine. You got result set which is forward only. You got result set which could be scrollable. Again, scrollable. It could be scroll sensitive or scroll insensitive. Fine. So if it is scrollable, whether scroll sensitive or insensitive, you can in such case use all the navigation methods. But if it is a forward only, you can't be using all kinds of navigation methods, row wise navigation methods. You can't use previous and methods which go back. It's a forward only. Fine. Okay, what's the difference between scroll sensitive and scroll insensitive? The scroll sensitive is, this result set is sensitive to the changes which are taking place in the result set. If, for example, yes, while I'm going through, I have obtained the result set already, and then once the result set is obtained, as I navigate and as I extract data from it, fine, if some data value is being updated in the result, in the database, which corresponds to this row in the result set, fine, if it is scroll sensitive, that change is going to be available to me. If it is scroll insensitive, once you obtain the result set, there's no change taking place within that. Fine. The changes are not reflected to you. Changes in the database would not be reflected. Fine. So, fine. So we got three types of result sets. Okay. But how do I specify? Where do I specify? When have I specified what type of result set I'll need? Okay, so if you want to specify what type of result set we need, it is determined by the kind of statement or the prepared statement or the callable statement which you use. Fine. So when you, how do you create a statement? Just hit create statement. Yes, in the connection, that method is overloaded. You could pass an integer as a parameter here. That integer value can be a constant. It's an integer constant available in the result set interface. So result set interface has this type underscore read only, or type underscore scroll underscore sensitive, type scroll insensitive. So these three constants, you could use any of these constants while creating the object of statement. So accordingly, so a particular statement only results in a particular kind of result sets. Okay, so one part is we have scroll sensitive, insensitive. One is the type of result set we have. Another aspect about the result set is whether the result set is read only or it is updatable. Oh, this is what we call as concurrency. So result set can have concurrency also. So result set concurrency determines whether this result set is a read only. So once a result set is obtained, you can only fetch the values from it, or is it possible to make updates in the result set, similar to what we do with cursors. Oh yes, we have cursors which are updatable, and we do make changes through a cursor, fine, in our SQL. So same way, a result set could be either a read only result set, or it can be a updatable result set. Yes, if it is a read only, yes, we'll be using only those getter methods, get xxx methods to fetch the values, fine. But if it is updatable, then it's also possible to make updates in the result set. Again, this concurrency, the type of concurrency, so for which again we have those integer constants, conquer underscore read underscore only and conquer underscore updatable. These are integer constants in the result set interface, which could again be used while creating the statement. So when you create statement, yes, you could be passing information related to result set type and result set concurrency. Okay, fine. So now let's see, if a result set is updatable, then how do we make updates in the result set? Okay, what other type of updates we can make? Oh, we can do a insertion. We might be interested in insertion, or we might be interested in a updation of a row, or we might be interested in deletion. Okay, oh, we are interested in deleting a row. Oh, that's the simplest thing. Yes, what we can do for delete, move to the, you have the navigation methods, move to the row you want to delete and just call the method delete row. Fine, that row would be deleted. Fine, so one is delete row. Another method available in the result set is the method, this would work, see, these methods are for updatable result set only, would not work for read only. Okay, so one is delete. Next is, yes, if I want to make some updates in my in a specific row in the result set, yes, what you do is move to that specific row, fine, and now once you move to that row, you got your you got a buffer in which those values for that row are available, for all the columns of that row are available. Now if you want to make any changes, what you need to first use the method. We have this again another set of methods, because each column has a different type of, may have a different type of value, the types of values are different, and if there are different type of values, you want to make changes in them, you got a different kind of methods. So here again, following that convention which we had with the get, we said we have the get xxx methods. Xxx could be any type. Same way here also we got a set of update xxx methods. The update xxx would take as parameter the column number and the value xxx, the value to be set in that column for the current row. So it's everything happens only for the current. So this will make changes only in the buffer of the current row. The table is not going to be updated by making update xxx. So update xxx is going to only make changes related to the rows, only making changes in the buffer of the current row. Once the changes are done, fine. Fine. So this you could use for making changes, and once those changes are done, you have a method called update row, which will then from buffer put it into the tables. Fine. So once so update xxx is one method, and then the other thing which we would like to be interested in doing is we would be interested in inserting rows into the result set. So for inserting rows into the result set, yes, we have a few steps here. What you need to do is what will be required to be done is you have a method called move to insert row. It's like opening up a blank row, fine, creating a blank row buffer. So move to insert row is the first method you invoke on the result set. It opens up a blank row, creates a blank buffer for us. Use the update method now to fill the values in the blank row, and then use the method insert row to have the row inserted. Fine. So insert, fine, insert row, that's a way you use the insert row method. Fine. And once the insert row is done, the insert row results in inserting the row. Not only inserting the row, it also opens up another blank buffer. So it's like when you say insert row, it's you are still in your row is inserted, but a new blank buffer is also available. So if you are interested in inserting a number of rows, let's say you are interested in inserting 5 rows, you will call the move to insert row method only once, use the update methods to fill up the row, use the insert row, that inserts one row, again only directly use the update methods to set up the second row, and use the insert row again to insert the second row, and so on. So you can have multiple inserts, fine, using only once move to insert row. Once you are finished with insertions, you need to use a method called move to current row. So move to current row is like switching back from insert row to the normal insert mode to the normal mode. So move to insert row is like moving into an insert mode, opening up a blank buffer, and move to current row is like coming back into the normal mode. Fine. So this is how you actually make updates into a result set. Fine. Having made updates into a result, fine. So this deals with updates in the result set. Another point was we have only seen the statement interface earlier. Fine. So like in statement, we have the interface called prepared statement. In prepared statement, we got a pre-compiled SQL, and we had mentioned that there we use question marks to have parameters. Parameters, find question marks to have parameters. So for each parameter which you would like to have, there's a question mark available. So once we said, okay, prepare statement. Now if you want to execute any of those SQL, which is a prepared statement SQL, before you execute the SQL, we need to set up the value for each of those question marks. That is, set up a value for the parameter. And for setting up a value for the parameter, we got again the set xxx methods. Set xxx takes as parameter integer for the parameter number, and second parameter for that set xxx method is the value you'd like to set it up with. So you got set xxx methods even in the you got this in the set in the prepared statement. Fine, the prepared statement contains those set methods. Another thing to note is a difference from statement and the prepared statement. In case of statement, we pass the SQL string each time to execute. So those 3 methods, execute, update, and execute query, they take a string as parameter. In case of prepared statement, these the SQL is already predefined. We call it as a pre-compiled SQL. So SQL is already known. So we got again those same 3 methods, but in this case they are without the parameters. So we got execute but no parameters, execute update with no parameters, and execute query also working without the parameters. So those could then be used for executing the, but one thing you should remember here is before executing them, all the parameter values must be set using the set xxx methods. Fine. So prepared statement has the a new set of methods, which is the set xxx methods, and also the 3 execute methods do not require a parameter. Again, now going further, we have the callable statement. The callable statement in turn, again, what is this callable statement? It was created using a call. Fine, it is a call statement which you are passing as parameter. Fine, you are executing a prepared statement, stored procedure or a function. Fine. When we define a stored procedure, remember the parameters. There are three kinds of parameters in our stored procedures. No, I am not talking about the types of those, the SQL types here. I am talking about the three kinds of parameters. We have in parameter, out parameter, or the in out parameter. Fine. A parameter in the in our stored procedure could be an in parameter, a out parameter, or an in out parameter. When we have a function, I said question mark equal to, that first one is also a parameter, and that parameter has to be considered as a out parameter because it's a return value. Fine. So stored procedures or functions have in, out, or in out parameter. So our callable statement, whatever question mark we have used, they would correspond to a in, out, or a in out parameter. So here again we have certain things. Okay, the procedure to be followed in order to execute a stored procedure or a function. Fine. First steps would be, you need to set up the values for all the in parameters, in and the in out parameters. We need to set up the values. This is similar to setting up the values in case of the prepared statement also. You are inheriting those set x methods here. So you got to use the set x methods to set up the values of the in and the in out parameters. Next, what you can do here is, whatever are the out parameters. Fine. So for all the out parameters, you need to let the JDBC driver tell the database system that yes, I want to be executing this procedure, but what are their data types? I need to have some variables where the values can then be captured. Fine, because these are the out parameters. So to set it up, yes, you need to indicate what is the type of each of the out parameters, and that can be done by using the method called register out parameter. So callable statement have a method called register out parameter, where the parameter is, first parameter is the parameter number, and second is the type. The type is an integer here which is coming from the types class, java.sql types. Recollect, that was the one which we had mentioned. Fine. Okay, which we mentioned at the time of result set metadata. Fine. Okay, so we have this method called additional method called register out parameter to set up the values of the to specify the types for the out parameters. So your steps would be, set up the values for in and the in out parameters, use the register out parameters, then execute. Once the execution is over, fine, once the execution is done, the values in the out and the in out parameter need to be now read by the Java application. Fine. So if you are interested in reading those values, the callable statement also provides us with the methods getXXX methods. Fine. So depending on what is the type, yes, you will use the appropriate getter methods. getXXX requires parameter number, and you will be able to read the out or the in out parameter value once the execution is over. Fine. So that's how you use the statement, prepared statement, callable statement. Okay, a few things about all the entire Java.SQL package. The entire Java.SQL package, all the interfaces, whatever we have used so far, all the methods there, they have a throws SQL exception. So we got a common SQL exception class which is applicable to all of them. So take care of that while developing an application. Fine. In JDBC, you'll need that throws SQL exception or try catch for the SQL exception. Okay. And of course, a few other things. All of these types, they have a close method. Right? We have the statement, prepared statement, callable statement, all of them containing a close, because yes, these are resources, they are connection, even the connection to a database. So all of them have a close method, fine, which is common to all of them. And you need to be, as far as connection is concerned, take care that you don't hold on to a connection for longer than needed, fine, because connection is a resource which would be used by, which would be useful for other users also. So normally in a distributed application where it involves use of a database. Fine. The server-side application which is trying to access a database should be just opening up, getting a connection, executing its things, and then release the connection by using the close method. Fine. Fine. There are some advanced features, like there are connection pooling features which are available in the JDBC 2. Fine. It's not part of the simple JDBC. Fine, because yes, we have JDBC and JDBC 2 as there are two specifications. Okay. Fine. That one, JDBC 2, is javax.sql package. Fine, which we are not covering in this module. Fine. Okay, and fine. So fine, that's what you should be knowing. Okay, fine. So that concludes the JDBC part 2. Fine. With this, you should be able to, I think, write simple applications which make connection to a database